Hey guys, Mr. T here, just recording a quick video on reducing balance loans or just loans for your purposes in high school. Notice it says 12 Gen MA here because the stuff you covered in Year 10 is repeated in Year 12 if you do general maths. So reducing balance loans, they're also known as principal and interest loans, are the most common method of borrowing money from financial institutions, which are banks and credit unions for us. So in this situation, when you're doing a loan, because unlike what we've been doing previously, which is investments, an investment, you put money in the bank, and then the bank pays you interest on top. So at the end of the time, you have a larger amount of money. You invested money in the bank to earn interest. But here, you're a borrower, and you need a big chunk of money straight up that you don't have right now. So you borrow the principal that you need from the bank and you agree to pay it back as well as interest with regular payments over a period of time. So basically, you're paying the interest. This time the bank is earning the interest from you. Financial institutions calculate the interest on the reducing balance of the loan, which is reducing because you're paying it off bit by bit. But each of your payments pay both the principal and a little bit of the interest that they're charging you. This is why it's also called a principal and interest loan. So that's a lot of information there. But mathematically, all you need to understand on your calculator is this. PV is going to be positive. Why? Because the bank is giving you a ton of money at the start of the loan. In an investment, it's negative because you're putting money in the bank. But here, when you're borrowing money from the bank, they're giving you a giant chunk of money, so it's going to be positive. PMT, this is going to be negative, because you're paying the bank back for your loan, or you're paying the bank back for their investment in you. And at the end of a loan, FV, you don't want to owe the bank anything. So FV is going to be 0. So the first little bit of notes is going to be this. Mathematically, what you need to know for TVM solver is PV is positive, PMT is negative, FV usually 0. Okay, so for the purpose of the video, pause it for notes. But I'll continue. Now, you've already got a formula for the interest earned on an investment. It looks like this. I'm not asking you to copy that again because you've already got it. I'm showing it because I need to compare and contrast it to the loan interest formula. Why do you need a different formula? It's because the interest charge on a loan is money moving the opposite direction. You're paying the bank interest. The bank isn't paying you interest. So, the interest on a loan, you need this on your cheat sheet, in your book, whatever, is the total repayments over the time period. Take away the debt that you've paid back over that time period. So, that's in words. What does it mean mathematically? This is the one that you need. Interest for a loan is equal to the payments times by the number of times you made those payments. Take away PV, take FV. So, for the purpose of the video, pause for notes. This is the one that you need to get. There's a interest for an investment formula that you've got previously up here. You now need this. This is the interest that you pay when you're paying a loan. Please make sure you get it on your cheat sheet. Your textbook does not give this formula. My formula works for loans that are both fully and partially paid off. Okay? Pause for notes, I'll move on. Let's do this example. Ryan takes out a 10 grand loan to be repaid over 3 years, 9.6% per annum interest compounding monthly. Calculate the monthly repayments. Hence calculate the total interest charged on the loan. And see what is the outstanding balance after 1 year of repayment. So as soon as it says compounding, you use the graphics calculator. This is the link on Daymap. Hit the test nav button. Let it load. It loads twice, I believe. Start twice. Hit the calculator in the middle. So I'm just going to resize this. Ryan takes out a 10 grand loan over 3 years, 9.6% per annum compounding monthly. So A. What's the monthly repayments? So, TVM solver, your working hours should be NI, PV, PMT, FV, PY, and CY, because in South Australia, they will remain the same. So, first thing that you can work out is the interest, 9.6. You're taking out a 10 grand loan, so the bank is giving you 10,000. So it's positive 10,000. It's asking you to find the monthly repayments, so we're going to put a star next to that. At the end of a loan, I want to owe nothing, so FV is going to be 0. Compounding monthly, and we're making monthly repayments, so both 12, 3 years, happening 12 times a year, so 3 times 12, 36. So I have everything I need to put in the calculator. Apps, finance, TVM solver, 36, 9.6, 10,000 positive. FV0, 12. Notice that it changes it to the same automatically. Solve for PMT alpha. Enter. Now it tells me negative $320.80 to round it to 2 decimal points. Monthly repayments. That's your first thing to get down. Answer to A. What are the monthly repayments? $320.80 monthly. B. Calculate the total interest charged on the loan. We have a formula for interest on loans. Interest on loans is PMT times N. So interest loan equals PMT $320.80 times by 36, because you made 36 payments of $320.80, minus PV, which was 10 grand, take away FV, which you got down the debt down to 0. So this little bracket is working out how much debt you paid off. Because we're pretending you paid off the loan, you went from 10 grand to nothing. So you paid off $10,000 of debt with your $320.80 paid off 36 times. Okay, so interest on the loan equals, second quit on the calculator, $320.80 times by 36, take away 10,000, take nothing, $1,548.80 of interest you paid off. Interest charged on the loan. That's the answer to the question, but for interest's sake, I just want to show you how much it actually cost to pay off the loan. Remember, to pay off the loan, you paid $320.80 36 times. $320.80. You paid it 36 times. So to pay off a 10 grand loan, you actually paid $11,548.80 to pay off thus. That's why your interest was $1,548. It's just $1,548.80 bigger than $10,000. Alright, just to show you how that loan works. You don't have to do this part in the star. I just want to show you how this comes about, because that formula is just a formula. And then lastly, C. At year 10, you don't have to answer questions like this, but because I've shown you how to use TVM Solver, you can actually do more technical stuff like this, so I might as well show it to you. What is the outstanding balance after 1 year of repayments? N, I, PV, PMT, FV, PY, and CY. So this is asking, what is the debt going to be after 1 year? If we look at the calculator, this is telling me the debt after 3 years, 36, is 0, which makes sense. You're taking the loan out over 3 years, so after 3 years you're going to have no debt. But this is asking, what's the debt going to be after only 1 year, which you haven't fully paid it off? So 1 year is 12 months, 9.6, everything stays the same, 10 grand loan. Negative $320.80. FV is what we're working out. To work out the remaining debt after 1 year of payments, because you haven't paid 36, you've paid 12 times. So on the calculator I go 12, negative $320.80, solve for FV. That tells me negative $6,979.81 to 2 decimal points. Why is it negative? Because you still owe the bank that money. Why do you owe the bank money? Because you've only been paying for 12 months, for 1 year, when your loan was set up for 3 years, 36 payments. Okay, so remaining balance after 1 year. Alright, so you don't actually have to answer questions like that particular one in year 10. But I'm asking you to because it's more advanced than what I'm going to ask you in the test. Focus on A and B, because that's really what you're going to be tested on. But I've shown you how to use TVM Solver, so you might as well be able to handle that. So your homework now is just this. Exercise 8A, reducing balance loans, question 5, 6, 7, 8, and 9. Alright, hopefully that helps you out, and I will see you in the next video.